Unit 3, Lesson 5, Ocean Water. Here are the vocabulary words for this lesson. Please make sure to have your science notebook out. Write these vocabulary words down and have them to study for the rest of the unit. In today's lesson, we're going to talk about the density in ocean water. The word density is the amount per unit volume of a particular material. Today, our material that we're discussing is ocean water. So we want to know how dense this water is, how heavy, okay, how many units per volume of the water we have. So if you look here, we know that pure water or fresh water is 1 gram per centimeter cubed. That's how dense this is. Now the typical ocean water would be 1.027 grams per centimeter cubed. So ocean water can kind of vary because of the salinity. The higher the salinity, the more dense the water would be because the salt adds weight to the water. So I want you to get your science notebook out and answer this question here. Why do you think ocean water is more dense? So go ahead and pause your video and answer that in your science notebook. That's right. And the ocean water is more dense than fresh water because it has more saltiness. The salinity is higher. So there it's more dense. So if we're looking at the graph over here on the right, we're talking about the pycnocline in the water. Now remember, that was one of our vocabulary words. Pycnocline is the zone of rapid change in density due to the temperature in the water and the salinity in the water. So at the top, we see the density levels, and they're increasing as they move to the right. And along the side, we see the depth in meters. So it starts at shallow and moves deeper as it moves down. So if we're looking at our pycnocline line here, the shallower the water, we can see the density is less. As the water gets deeper, then this line begins to plummet very dramatically. So I want you to write in your science notebook, why do you think this happens? Yes, we know that as the water is deeper, the temperature is colder. So we do have a temperature change, and also there's not as much heat happening in the shallow parts. Okay, as you get deeper, not as much sun reaches those deep parts of the ocean, and so there's not as much evaporation. It's more salty down there, so it's definitely, the water is more dense in the deeper levels. As you might expect, the densest layer is on the bottom and the least dense layer is at the top. This is because the denser fluids sink just like denser air sinks. The layer of density are also affected by water temperature. So the deep cold water is the densest, and the warm shallow water is the least dense. Temperature affects the density of ocean water. If you look here, you can see 3 pictures of the water molecules and how they change and at different temperature levels in the ocean. So on the far left, you see the image of the heated water molecules. As you can see, they are further apart. We know that the ocean water will absorb heat from the sun, and so in those shallow water, it's going to be warmer water. So this picture depicts what the molecules would look like at that level. When liquid such as water is warmed and the molecules move faster and they bump into each other, they spread further apart. This is what you would see. They take up more space, and they also increase the volume occupied. So as it gets colder, the water is denser. And this is because the molecules move more slowly, taking up less space. So if you look at the middle picture here, you see the cooled water molecules. So they're starting to cool, and that denser water will then start to sink towards the bottom, while the warmer, less dense water is going to stay on the top. And again, on the far right, you can see deep water and how the molecules have gotten closer together and are moving slowly. And as we were talking earlier, the salinity affects the density of the water also. The holocline is an area of changing salinity. So if you look at the graph on the right, you can see the deeper the water, the more or higher salinity it will have. It increases. If you measure salinity in various oceans or lakes or in the same ocean throughout the year, the salinity will differ due to the weather conditions. So let's look over here and answer a couple of fill-in-the-blank questions. First one says, as water temperature decreases, water density, and then you're going to fill in the blank. So go ahead and pause your video and write this in your science notebook and fill in the blank here. And that is correct, that water density would increase as the water temperature was getting colder or decreases. So water density increases when the temperature decreases. Okay, number 2, as concentration of salt increases, so as the salinity increases, the water density also, go ahead and pause your video and write this in your science notebook for me. And it also would increase. So we know the saltier the water, the more dense it will be. So to finish up the lesson today, we're going to go through a couple of multiple choice questions that are to review what we've learned about ocean water. Here's the first. What is the most common salt found in ocean water? Please take a moment and pause the video and choose your answer. Sodium chloride would be the correct answer. Which statement best explains the relationship between an area's geography and the temperature of its surface water? Please take a moment to pause the video and answer the question. The correct answer is A. Areas at low altitudes have the warmest water, because they receive the most direct sunlight. What conditions would most likely cause a decrease in the salinity of ocean water? Please pause the video and pick the best answer. A river flowing into the sea is the correct answer. Make sure to complete lesson 3.05 and keep an eye on your email and your gradebook. Ensure all lesson and work is complete. Thank you and have a great day.